Swayam Prabha. Digital India. Educated India.
Dear friends, welcome back. In the last few lectures, we have been discussing about some of the examples of system design. We discussed how the system design principles can be applied to some practical examples. So, we saw one example on the vehicle navigation system design, basically for helping the drivers as well as passengers to find out the location and navigation supports. That was one example, which is auto link system, and then we have been discussing about another example on another system design, basically known as Insights. Basically it is a institute service kiosk terminals. So, we discussed about the objective of this particular system and what are the basic requirements and how do we identify the requirements through scenario analysis and input output trace. And then we discussed about the requirement identification and how do we develop the originating requirements document or ORD. So, once we have this, we discussed about the context diagram and then what are the external systems associated with the main system. And the next task is basically to go and analyze the functions of the system, or we go for a functional decomposition. So, as we explained in the previous lecture, the system context diagram is shown here. So, this is the system where we have many subsystems and external systems acting or used in the main system. So, the context diagram shows the GPS system as an external system, then other service providers as external system, user as an external system, and then the server and database as external systems, and of course all other peripheral devices also. The main objective, we already explained that it is basically to provide the services for the visitors as well as to the students. So, in order to do the functional decomposition, we use the method IDEF0 when we discussed about functional decomposition. So, IDEF0 is a diagrammatic method of decomposing the functions into sub functions. So, here we have different diagrams like A0, A-0, A1, A2, A3 like that. So, A0 is the context diagram. So, here in this diagram we will show the system as well as its external systems and the context in which the system is being used. So, the main function we can say provide directions and other navigation details to the visitors. Of course, you can have additional functions also, but here we show this as the one of the main functions, and then what are the external systems and interactions needed for the system are shown here in the context diagram, and then Insights is the main hardware which actually provides you this function. So, this is the context diagram or A0 diagram, and then we try to decompose this function or this diagram into sub functions. So, we start with this main function provide directions and other navigation details as a main function, and then decompose this into sub functions. So, when we decompose, you will be getting the A1 diagram. This is the enlarged view of the previous diagram. So, for better clarity, we have shown it as a separate diagram. So, here you can see this is the main function provide directions and other navigation details, and then you have the hardware which actually provides this main service, and then you have the maintenance services and maintenance system as an external system, and you have all other external interactions and external users, the different types of users, then the user request, different kinds of requests, and then the destination information, and then the request from customers. Similarly, the output from the system as acknowledgement, and then location details, navigation details, and then printouts. So, these are the outputs, these are the main inputs to the system. Now, we will try to develop it further, or we will decompose this function further using IDEF0 method. So, we will go for the A1 diagram which actually shows the sub functions which can be identified from the A0 function. So, the A0 function is decomposed into 4 main functions here, as you can see: accept request, process request, search database, find routes. So, these are the main 4 functions which can be identified from the A0 function. So, the A0 function is decomposed into 4 functions here, and then you can see the type of interactions taking place between these functions and the inputs coming to these functions as well as the outputs from this function. So, you can see the inputs are basically the user request, then the power supply, and the database and other infrastructural support, and then you have the output as acknowledge request, then the display directions and print map. Depending on the request from the customer, we can actually provide a printed map or other kind of output. So, these are the interactions taking place. So, it is not only the interaction with outside systems, basically we will be having a lot of interaction within the systems also, within these sub functions also there will be a lot many interactions. So, the output from this will be going to the process request, that the request will be processed here, and the process request will be sending the data to the search in database function. So, here the digitized request will be passed to this function, and then the output will be passed to the find routes function, and then finally the output will be given from here. So, these are the 4 functions which can be identified from the A0 function. This is shown with a bit more clarity here in this diagram. It is the same diagram which I explained earlier. You can see here this is the accept request function with the user request for directions and the input power supply as the inputs, and then you have this output coming from here to the process request function, where the digitized request will be going to the search database. So, here the output will be acknowledgement of the request, then the search in database, then find possible routes, and that route will be displayed as the output to the customer. So, these are the 4 main functions we can identify from the first function. So, this diagram is known as A11 diagram. So, here actually we are decomposing the A1 function into 4 functions. Now, all these functions can be decomposed further into small functions. So, we take one function here and then try to decompose that into small functions. So, we can take accept request as one function, A11 function, and then we will decompose this A1 function, then we will decompose this into sub functions. So, that is shown here. The accept request function is decomposed into small functions here. So, this is the accept request, the first function, then digitize request is the next function in that one, and then once you have the digitization of the request, it will be passed to the next function. This is basically acknowledge request. So, there is another function to provide an acknowledgement or the output to show that the request has been accepted, and that will be giving the output to the main to the next function, which where actually the output will be shown as a display or as some kind of a feedback to the customer. So, these are the sub functions which you can identify from the A1 function. So, this is A11 diagram. So, you will be having 3 sub functions here: accept request, digitize request, and acknowledge request. Same way we can actually further decompose this into small functions. Like this we can actually decompose all these functions into small functions, and then we can get complete functional decomposition of the system. So, once we have the complete decomposition of the system, we can actually develop a functional decomposition chart. So, functional decomposition chart is an output of the IDF0 diagrams. So, we take all the functions identified in the IDF0 diagram and then represent them as a chart, as a hierarchical chart that will give you the functional decomposition. So, once we have the functional decomposition, it actually tells us that what are the functions to be provided in the system. As we saw in some of the previous examples, we can actually write down all the functions like accept request, digitize request, acknowledge request, like that, and that will provide you a hierarchy of functions. And based on this functional hierarchy, we can actually develop a physical architecture. As I mentioned earlier, there are 2 types of physical architecture we develop. One is the generic physical architecture, the other one is the instantiated physical architecture. In the generic architecture, we will identify the generic components to provide the functions, and in the instantiated one we will try to give the details of these components which actually can be used for that particular function. So, what we have shown here is a generic physical architecture for the insects system. As you can see, there are multiple sub functions we need to provide in the system. I have not shown the complete diagram here because of the lack of space and to show the whole structure here. So, here you can see the user interface is one important sub function which actually provide you input and output from the system. So, that is one sub function. So, for that we need to have a user interface. So, user interface components is one, then the GPS and navigation aids, then communication module, then power module, then other input output modules also will be there. So, here again for the user interface we can see that there are different kinds of inputs and output requirements. So, we can use keyboards or touch screen, telephone, speaker, display screen, printer, fax. So, these are the components which can be used for the user interface. Similarly, for GPS and navigation aids we can see there are receivers, transmitters, processors and database server as the components for providing this particular function. For communication module again we can have network components and other hardware, and then of course we can include the software also for communication. Then power module also we can have the normal power supply or the battery power supply as the additional components over here. So, like this we can develop the generic physical architecture, and in order to get the instantiated physical architecture we can go for the morphological box and identify the components which can be used for these purposes, and we can see what kind of actual component or what device need to be used for these purposes. So, that is the next task. So, we can go for morphological box and then get the details. So, here again we have different options. I am just showing a very simple example here. We can actually go for all components, you can have actually develop the morphological box. So, here I have shown the display, the telephone and the network options, as well as the printers and the direction showing options, and the database options, the network options. So, here there are taken few components and then develop the morphological box. As you can see, for the display you can have a different kinds of monitors, CRT, LCD, electronics or plasma display or touch screen display, and for the telephone you can have a codeless phone or with the code or with or mobile phones. You can have a network, various existing network can be chosen, or you can have a dedicated network for the system. You can have different kinds of printers, inkjet or dot matrix. For the directions you can have different databases, or you can have the already existing softwares or algorithm can be used for this purpose, and the database can actually be again chosen from the existing database, or we can develop our own database. And then local area network can be opted based on different options available. We discussed about the ring or master slave or bus architecture. So, we can actually choose any one of these architecture for the network. So, like this we have different options, and based on this morphological box you can choose component for input, output as well as the directions and navigation, and that can actually be shown in the architecture. Then it becomes a instantiated physical architecture. And apart from these requirements identified, we will be having redundancy requirements because of the fault tolerance. So, we need to have methods to prevent the fault spreading to other parts. So, we can have various kinds of fault detection methods. So, we can actually have fault detection for the following cases where the user or support feedback system fails, the access to printer or fax telephone fails, power supply system fails or transmitter fails. Of course, you can identify many other scenarios also and try to provide the redundancy requirement for these cases. Here I have provided a few cases, basically for when the transmitter fails or from the satellite GPS data fails, then we need to have a hot standby system. A hot standby sparing system can be provided to get the signal from the satellite. So, we can actually have transmitters, more than one transmitter to transmit the signal from the satellite. So, we can have them in the hot standby. The hot standby is basically all these transmitters will be in on condition, and there will be an error detector in this one with a specified error declared here. So based on that, this will declare whether there is an error or not. If there is an error in this particular transmitter, then automatically data from this transmitter will be accepted by the control unit, and the control unit will give an output to the system here. So based on this, the data will be accepted. So depending on the health condition of the transmitter, whichever the transmitter is in good health condition will be used for providing the data. So that is the hot standby sparing methods. And similarly for the support or feedback system fails, so we can actually have a triplicated TMR kind of method over here. So when the feedback system fails, so we can actually have different ways of connecting the user input to the system. So if one of the method fails, other system will be available for connecting. So the user data, if we are using a keyboard or any other interface device, if that fails, we need to have additional devices to provide the interface. So we can actually have them in the triplicated TMR model, so that any failure in one of the inputs can always be taken care of using these methods. That is one way of providing the standby sparing methods. Similarly for the printer, we can actually have multiple printers in the cold standby mode. So we can actually connect to one printer, and whenever there is an error, this will be actually connected to the printer 2. Automatically it will be redirected to printer 2, though the printer 2 will not be in on mode. So you can actually keep it in cold standby, and whenever needed it can be activated, and then it can be used for printing the output. So this actually can be in a cold standby, because the time delay in activating this may not be a critical issue here. That is why we can have it in a cold standby methods. Same way we can go for the power supply system fail also. So depending on the time required to connect to the backup power, we can have it in a cold standby mode, or if it is very critical, we can go for a hot standby also. But in this case, even if the power fails for a few seconds, it is not a major issue. So we can actually connect it in a cold standby. We can have a power backup in cold standby. So whenever the main power fails, we can actually connect it to the backup power, and then it can be used for controlling the system, or it can actually be powering up the system. So this again, it is a method of providing a standby power supply to avoid any faults in the system. All these methods actually provides fault tolerance for the system. This actually shows the weightage allocation of the system. So we know that there are multiple requirements for the system, and then we need to have some kind of priority in assigning the task or assigning the system functions. So we can actually see that the operational objectives are given the higher priority over here. So 0.65 is given as a priority for the operational objectives, maintenance is given 0.35. So this again depends on the designer. So designer can actually decide which one is more important, the maintenance functions to be given priority or the operational objectives to be given priority. So this priority operational objectives can actually be again the priorities can be assigned to the sub tasks in the system. So here you can see that in order to achieve the operational objectives, these are the sub functions needed. So again we saw different methods of calculating the weightages. So using those methods we can actually go for calculation of the weightages for various functions, like the storage capacity, the number of simultaneous inquiries to be handled, speed of data transfer, speed of the system, then security for sensitive data, ease of use, and these operational objectives, the weightage need to be provided to these objectives based on the overall weightage assigned to that particular function. So here operational objectives is given 0.65, maintenance is given 0.35, and again the sub functions in the maintenance is given the weightages based on the importance of those functions. So this is how we provide the operational objectives to the hierarchy of operational objectives and allocation of weightages to various functions. So this actually gives us an idea of how the system design starts from the initial identification of operational objectives, and then going ahead with the identification of the actual requirements of the system, then identifying the context diagram or developing the context diagram, then looking at the external systems, and then input output requirements. Then we go ahead with the complete requirement identification, trade off requirements as well as system wide technological requirements. Based on that we develop the originating requirements document, and then go ahead with the functional decomposition, functional hierarchy, physical architecture, then other functions for fault tolerance, then objectives and weightage allocation for various objectives, trade off, and then we go for the actual system design, development of the physical components or selection of physical components, and then integration of these components. And as we go with this, we need to go for the development of testing and evaluation criteria, and then once you have the system, we do the testing and evaluation and then accept the system. So that is how we proceed with the design of system. So all these examples I am not showing the complete procedure and end to end process, because this idea of this is basically to tell you that how to use the principles whatever we learned in the system design in a practical situation. Whenever this actually gives you an idea how this can be used for real scenarios. So in order to emphasize this, we will take one more example, again a simple example, and highlight the importance of various system design principles and use of these principles in the system design. So this system is defined as or it is named as UDARES. Basically it shows that unified data recording system. Again it is a practical example which we developed for a practical application. The objective of the unified data recording system is basically to develop a unified data recording system to monitor and control the academic, administrative and other day-to-day activities across the campus. Again this is developed for practical application on the campus. So when you have a unified data recording system which can actually be integrated with various activities of the campus, then that becomes a complex system where we need to record a lot of data from various sources like the student attendance, the faculty and staff attendance, as well as their salary details, then the type of projects taken up by the faculty and all other administrative functions and academic activities like registration of courses, allotment of slots to the courses, then timetable management, registration, PhD, MS and other research project registrations. So all these things can be combined to a single system where we can have a single database and various terminals to record the data, and then various terminals to access the data at various levels. So here we are looking for a unified data recording system which can be used for various activities in the campus. We will try to see what are the main objectives and what are the main functions to be provided, and then we go ahead with identifying the different subsystems and components in order to achieve these functions. So as I mentioned, the main objectives are online recording and compilation of attendance for students, staff, faculty on a day-to-day basis, real-time analysis of slot-wise engagement of students or faculty, online compilation of student grades and teacher course feedback, integration with the online database of central library, as well as it serves as a real-time database for leave, salary and scholarship computation, monitor usage of various facilities like mess, student facility center, gym, swimming pool etc. by the students as well as staff, record faculty, student, staff usage of common services like hospital, engineering unit, the institute, and usage of the data for futuristic planning, enable cashless transactions at various campus stores. So apart from the acting as a data storage or recording system, it can actually be used as a cashless transaction device also. Then develop an online database for projects undertaken by industrial consultancy and sponsored research, and provide online access to financial information. So these are the main functions identified for the UDARES system. Now how do we provide these? So we need to look at the context diagram and what are the various entities which will be interacting with the system. So if this is the UDARES system, then these are the external system that will be interacting with it. So you can see that these are campus services, faculty, students and staff, then library, IC and SR, Gymkhana and administration. Of course, the administration includes the financial as well as academic activities. Then the network through which all the data will be transferred or exchanged with the different agencies or the subsystems. So, that is the context diagram for the UDAIR system. Now, we look at the UDAIR life cycle. If you want to develop the system, what will be the life cycle of the system? So, in the development phase, that is the main phase where we are looking at. So, we need to identify the type of devices. When I said scanners, basically the type of hardware devices needed for data entry as well as for storing and the locations where we need to provide these scanners. So, the type of scanners, number of scanners, method of communication, processing techniques, all these things need to be developed in the development phase. So, this is only a few things. So, we need to go for many more things in the development phase like the architecture, communication architecture, then network architecture, all those need to be developed in the development phase. And then it is the assembling or the integration phase. So, we have assembled the various subsystems to a main system. So, whatever the hardware we identified, we try to integrate them together here. If any development or new design need to be done, that also will be done. Then we will do the assembling of various subsystems, then configuring of networks and connecting subsystems to main system in the assembly stage. Then we go for the testing. Here testing the working of various subsystems individually and collectively to check the process parameters. So, we will run for a few days or few weeks to see whether the system is working perfectly, and depending on the output, the refinement of the system will take place. And once that is done, then it will be deployed for operation. So, then this is the deployment phase of the system, and once deployed, then it will be more like the maintenance. We need to maintain the system. So, the maintenance phase requirements need to be identified, what kind of checks to be done, what should be the repair time and recuperation time for a system, that is if something goes wrong, how long it will take to come back, that is with the MTBF and MTTR. And after the maintenance phase, basically we will be looking at the refinement. So, what kind of improvement need to be done, whether any update to be made, and what kind of new facilities can be added, and what are the features need to be provided for futuristic expansion. So, all those things will be done in the refinement phase. And then the last one is the retirement phase. We need to see when actually we have to see the system can be replaced completely, or if we want to replace, what should be the process of replacement, how do we actually dispose the hardware as well as other components associated with the system. So, that is the retirement phase. So, when we design the system, we need to look at all these phases and then design. So, we will start with the development phase, and then we will go through various stages of assembly, testing, then maintenance, then refinement as well as the retirement phase. We design the system for all these phases. So, we will not be going all these phases in this example. What I am emphasizing is that it is not only the development phase what we need to be worried, we need to look at all these phases when we design the system. So, here the scope of the project will be limited to the limited data recording and retrieval by students. So, these are some of the project limitations or the constraints we impose on the system. So, the data recording and retrieval by students will be limited, the data recording by all the staff and limited retrieval by authorized staff. So, all the staff can actually record the data, but retrieval will be only limited to authorized staff. Unlimited data entry and limited retrieval by faculty, cashless transaction at select establishments and centers only. So, these are some of the constraints we identified in the early stage of development. Here the system operation, we look at the scenarios in order to identify the requirements. So, as I discussed or explained in the previous case studies, we need to look at the various operational scenarios in order to identify the complete functional requirements. So, before we start the development, we look at all possible scenarios and then identify the requirements. So, we can actually go through many scenarios. We saw this in the previous examples also. So, here I will not be going through all the scenarios and explaining how to get the requirements. We will just take one or two scenarios and then show how the requirements can be identified from this scenario. So here the one scenario is shown as faculty records daily attendance. So here an input data device connected to the network display the options available. So that is the first scenario where an input device is provided to the person and it actually shows the options for available. So this is one scenario, and from here we can identify many requirements. The one requirement is that a portable device is needed for recording the data. So it should not be a fixed one, it should be a portable one, and that should be having many options displayed. So there should be a possibility for displaying the options in the device itself, and it can be connected through a cable or wireless. So this scenario shows that these are some of the requirements of that particular scenario. Then here faculty chooses attendance records, then the system asks for authentication and faculty provides authentication. When we say faculty provides authentication, that means there should be a provision to provide the authentication. So this can be in different ways. It can be a password authentication, or it can be a fingerprint authentication, or it can be some other way of authentication like a swipe card or magnetic cards. And then system accepts authentication and displays the options available for the faculty. Faculty chooses course name, then system displays student name and offers opportunity for faculty to enter data, and then faculty enters data and completes the process by logging out. So this is one scenario where faculty records daily attendance. While going through this scenario, we can identify many requirements needed for the system. So the objective of explaining the scenario is to look at this scenario and identify various requirements. As you can see here, we can identify many requirements. So if we say that faculty chooses the course name, that means it should be options should be provided to the faculty, or the database should have all the courses where the faculty is registered, and then all the data corresponding to that course in terms of student name and their roll number should be available. Then only the faculty can actually record the data, and then faculty enters data. Again, need to have some facility for the faculty to enter the data to the system. So these are all the requirements which can be identified from this particular scenario. So we can actually represent the same thing by using an input output trace. Again, we saw this in the previous examples also. So we will identify the external system here, and then the UDIR system as this one, then the type of interaction taking place between the faculty as well as the system can be represented here as inputs and outputs from the system. So this will tell you what kind of input is coming to the system, and then how do the system accept that input. So the request to access with portal, so what kind of an input is coming and what kind of output to be given can be identified here. So same way we can identify all the inputs and outputs and can be shown as a input output trace, which will help us to identify the requirements for this particular scenario. Once we do all these scenarios, when we develop these scenarios for various, or when we look at various scenarios and then try to identify all the requirements, input output requirements as well as system wide requirement, trade off requirement, then we try to develop the originating requirements document. So originating requirements document will record all the data in a systematic and in a predefined way with some rules and procedures to record the data. So this originating requirements document becomes one of the most important document in the further development of the design. So we go through all the operational scenarios, all the system wide requirement, trade off requirements and technology requirements, and then record that in the ORD, not only for the development phase. So it will actually consist of all other phases like maintenance, then refinement and retirement also. So various phases will be considered, and all the requirement for these phases also will be recorded in the originating requirements document. So this actually shows few requirements identified for the operational phase. Input output requirements: the system shall accept identification details from professor or student staff. The system shall give feedback to user within X seconds. The system shall display fonts at least to the size of Y. The system shall have provision to enter fees payment details by the bank personnel. Similarly, the system shall have provision for auto generating mail for request of a slot exchange with other faculty. The system shall have provision to send email to students notifying them regarding scholarship, etc. The system shall compile the staff attendance data. The system shall send mails to the students regarding changes in the class schedules. Of course, these are not complete, just sample requirements. Similarly, for technology and system wide requirements, the system shall auto save data every 30 seconds. The system shall allocate 1 GB space for every faculty, 500 MB space for every student staff. Of course, these numbers can change, but this actually shows that we need to identify this requirement also and record it. Then the system shall have a processing speed of 5 GHz or more. The system shall use the protocol 6 or more for the networking applications. So this again, these are the technology or the system wide requirements. So we record all these in the originating requirement document, and this gives the external system diagram. You can have various external systems and how they are interacting with the main system. So you can see these are the external systems, the students, staff, faculty, then the hardware systems, then the server, maintenance personnel, then maintenance system, then there are software regulations, then of course other things like building and other infrastructure also will be coming as external systems, and the input will be the request for UDAIR services, and then output will be UDAIR services coming from the system. So this is the main system and these are the external systems, and this shows the input and outputs. Of course, there are various inputs and various outputs coming from the system. Okay, this actually shows the details of the external system diagram which we showed in the previous one. So here you can see that faculty, staff, students are the external systems here, then the server, then administration block staff, then maintenance people, then the housing or the infrastructure, then the display unit. These are the external systems, and then you have the main system here which actually provides all the information. So here you can see these are the main functions. So request for decides data service, then provide service and provide information, and monitor operations. So these are the functions to be provided by the UDAIR system, and all other external systems are shown here, and the type of interaction with the external systems also shown over here. You can see that the inputs and outputs from various functions are shown here in this diagram. Okay, for functional decomposition, we saw this in the previous examples. So we start with the A0 context diagram. We identify all the inputs and outputs. So these are the inputs to the system, and this is the main function of the system providing UDAIR services, and this actually shows the outputs, what kind of output is coming from the main system. So the request all the outputs whatever we discussed in the previous slides. So updated attendance database, mail request for slot exchange, scholarship allotment and updated databases, then staff attendance fees database, all these will be given as output from the UDAIR services. You can actually go for further decomposition using the IDF0 diagram as we explained in the previous cases also. We can, this A0 function can be divided into A1 function, A1, A2, A3 functions like this. So these are the sub functions we need to provide, like user identity authentication, accepting user request, then control operation, then provide utility services, and then maintain services. So here you can see the detailed A0 diagram. So these are the sub functions A1, A2, A3 and A4, A1, A2, A3 control operation, then A4 is provide utility services, then maintenance and repair. So these are the 5 sub functions need to be provided in the system, and their interactions are also shown, what kind of interactions are taking place. You can see there are different inputs coming to the system, data request, navigation, cashless transaction request and other services, and for that one we need to provide all the these inputs will be going to these functions, and then the input will be processed and the output will be provided over here. So that is the output from the first level diagram or A0 diagram. And then we have the further decomposition. If you take A3 function, the A3 function can be decomposed into A31, A32, A33 functions, and then we can see that these are the process request, search for data and extract data are the sub functions, and again the outputs from this will be the details, information, transaction details, then feedback, Similarly, you have the data search request and cashless transaction request and other requests coming from the customer. So, these functions process this data and give an output. So, this is the way how we actually go ahead with the IDF0 decomposition of functions. And this shows the decomposition of A32 function. So, A32 function the input is login and password, then it connect to the network, search for desired data in the network database and then provide the data output. So, A32 will be having two sub functions A321 and 322 and that will be providing the extracted data from the network to the next function. This is the 332 diagram. So, here actually this 332 function is decomposed further, find the category of information asked by the user, then collect data from the corresponding category and extract the data and give it as an output. So, once we have all these functions, we try to prepare it as a functional hierarchy diagram. So, we will provide the top level function over here, provide user services and then write down all the sub functions identified, user identity authentication, accept user request feedback, then control operation, provide services and maintenance and repair. And for all these functions we will be having sub functions identified through the IDF0 diagram. So, we will take the one example here A3 and for A3 we have many sub functions identified A31, A32, A33 and then again A32 has been decomposed further to A321, A322 and again A322 is decomposed into A321, 322 like that. So, all these functions can be shown as a hierarchical way which will give the functional hierarchy of the system, and based on the functional hierarchy we can develop the physical architecture. This shows the weightage allocation for various functions in the system. So, we can actually see here this is data gathering is given a weightage of 0.3, compilation and updating of data given a weightage of 0.3 again, then display 0.2 and other features 0.1 and maintenance is given a weightage of 0.1. So, this actually helps us to have the hierarchy of functions and then their weightages in order to have some kind of trade off at a later stage in the design. And again each one will be having sub functions and depending on their importance it will be given weightages accordingly. So, here you can see this particular data gathering is given a weightage of 0.3 and within that there are many functions like speed of process, accuracy of data gathered and maintenance of gathering devices. So, these have been given the weightages 0.2, 0.5 and 0.3. Again there are mathematical methods to identify the weightages. So, we use those mathematical methods and identify the weightages for each function. The same way it is given for this one also, speed of process and consistency of compiling and updating, and here it again displaying the data to users has got features shown and then the privacy of users and users ease of using the display. Again weightages are given accordingly. So, these weightages allows us to have the trade off at a later stage if we want to modify the design or we want to have some kind of trade off. So, that is about that trade off. Then here it shows the morphological boxes. As I told you about the physical architecture development, in order to have the instantiated physical architecture we will try to identify the various options for input and output and other functions. So, this actually shows different options for various functions here. So, this is one function where you can have the user authentication. So, you can use password, iris reader or fingerprint screen or photo verification or voice recognition, and similarly for networking you can actually use for Bluetooth or LAN or WiMAX or Wi-Fi, and for the authentication we can use the plastic cards or vinyl coated paper or FRP as input devices. So, these are the options shown for various functions, and we can choose any one of these and make a combination of these to get the instantiated physical architecture. This shows the morphological box for various components for information exchange, processing component, then number of nodes, network architecture component, information display, information entering component, then information processing component and error detection component. Of course, we have the error correction component, threat correction component and threat detection component also, and we have different options for all these components. You can see here, you can have firewalls or virus scan device methods or antivirus options, parity corrector or parity checking. Then we have the options for processing component, whether 2 GHz or 1.66, then the keypad options, the display screen options, nodes options, then we have the processing component option, whether it is 5 GHz or 10 GHz, and what kind of server to be used for information exchange. So these all come from the morphological box, and depending on the requirement we can choose one of these and then develop the physical architecture. So once we have the physical architecture, then we go ahead with the same method as discussed in the previous cases and go ahead to complete the physical system development. So one important point is the interface design. So as we discussed in previous cases also, interfaces are one important point or failure point which we need to be designed with full attention, so that there will not be any failure in the interface. So we can actually have different operation concepts for the interface. So if you take this interface requirement of transfer of data between different modules, we can have different options. So we can have an intranet as an operation concept and then identify the architecture for that particular interface. So you can have different options like Wi-Fi or LAN cables or telephone connection. Then based on your own assessment, you can actually decide which one to be chosen. So based on the pros and cons of different options, you can choose the desired interface. And then the next one is the integration and qualification of the interface. So again, when we have this selecting one of the interfaces, there will be many interfaces to be chosen. So we choose all the interfaces, all the components, and then have the system integration and then qualifying the system. So once we have this identified all these interfaces, components, then we go for selecting the components and then integrating them, and then as per the standards set for the qualification and inspection, we will complete the system design process. So that is how the particular system design process starts from initial concept to the final system integration and testing, qualification as well as acceptance. So this completes the examples what I was discussing for the last few classes. Basically the objective of these examples were to tell you how to use these principles in the real scenarios. So whatever we learned in the last 20 lectures can be directly implemented in any practical system design, and we can see that when we provide when we use a systematic way of system design, we can get real benefits, and it is very easy to make modifications or go back and then redesign the system at a later stage. Apart from the system design principles already we saw, there are few additional topics need to be covered as part of the system engineering design course. We have many graphical modeling techniques to be employed for system design, and there are decision analysis for a design trade-off. So we need to make many decisions, most of the times under uncertainty. So how do we actually make decision based on this, and then how do we do the system reliability analysis, and how do we identify methods for improving the system reliability, and then some statistical tools for system design. So we will discuss about these topics in the next few classes, and till we meet, goodbye to all of you.